I'm pretty sure you've clicked on this video because you want to imitate how scopes are done in games such as the more modern Call of Duty games. And you might be asking yourself what makes this one different from the others using the industry standard picture-in-picture method. This is a guide into how to implement a post-process based zoom on scopes in Unreal. If you have any experience with Unreal before, usually you know that scope zooms are implemented by picture-in-picture. There are many guides in that you can find. Now, the main problem with picture-in-picture scopes is that they are very usually performance hungry. This video, I'm introducing a method that aims to be light on performance while still achieving the desired effects of the zoom in the picture-in-picture. Before we start, some disclaimers. First, if you're not familiar with picture-in-picture scopes, I recommend that you first see how that's done. This guide assumes that you are familiar or have used picture-in-picture scopes in the past. Second, as of posting this video, assume that this is just an experimental application and it might be hard to find solutions for the edge case problems on the internet. This might change, who knows. Third, this is not a flawless solution. Much like the picture-in-picture method, there are caveats and issues that I will discuss later. And also, there are some things that make this method more complicated to use. All right, now that's sorted out, let's begin. To start, I will create a new UE5 project for this demo. If you're following along, I named mine scope_post process and selected the first person starting templates. I'll skip ahead after the project is already generated. Right, with a fresh project, check if it's properly working. I'm just gonna tidy this up and yeah, let's put that and yeah, there we go. Now to create a post-process material that will create the scope zoom effect. In the content folder, create a new folder named scope PiP. Yeah, let me just get that. And under that, create another folder named post-process just to keep things tidy. Right, now open that and create a material and name it m_site_post-process. Right, now open that, the newly created material. Now select the endpoint of the material. First, you need to change the material domain to post-process. Okay, that's for the setup. Now, just checking. Right, all good. Now, for the peripheral vision, create a screen aligned UVs node. Right, this section is for the outside of the scope zoom. Right, next up, we need to create a scene texture node. Need to change the scene texture ID to post-process input 0. And connect the X and Y pin to the UVs. Then after that, drag the color pin and then create a component mask node. Now make sure the colors are the component mask RGB is checked. This section will serve as our peripheral vision for the scope. This will have no magnification because it is outside the scope area. So no post-process, just the regular view. Next, let's create the zoom area. First, just copy and paste the screen UVs nodes, drag the X and Y pin, and then create a multiply node. After that, create a scalar parameter node. I'm just straightening that out. Next, create a scalar parameter node. I'm naming that zoom scale. And then I'll make the default value 0.5 for testing purposes, just to make sure it's zoomed. Then connect the output to the B. Yeah, you can change that later for your desired zoom. Right now, drag out the pin from the multiply and create a breakout float components. Then, as you can see, it's going to break out the R and G. Uh, Drag both of them and create add nodes for both of them. All right. Then connect them both to each of them. Just trading it out. And after that, at the end of both of them, create an append vector nodes and connect both the add nodes to the append vector. All right. Right after that, okay, just trading this out. This section, yeah, yeah, all good. Okay. Right, next one. We are creating custom nodes. I'll explain short. This allows you to create a small snippet of code that executes in the material. So, okay, I'm just searching for it. Should be custom. Custom. All right, there we go. In the custom nodes, you need to change the output type to CMOT float 1. Yeah, just changing that. And then change the description to which you like. I named mine calculate UV scale offset to center screen. Mhm, mhm. All right, next I'm gonna correct the inputs. All right, under the inputs, grade 1, there's already there. I changed the name of the input to input name to scale value, just to make it easy to understand. Right. Okay. Now that's done. Let us do the most important part, the code field. All right. Use this formula to create a return statement. Uh, yeah. Change the X to the input name. So raw code, what it would be is return open parentheses 1 minus scale value, closing parentheses, multiplied by 0.5, closing parentheses, percentage 0.5. If you notice, I made an error on the uh, code I typed. I'll correct that later, but it should be 0.5, not 0.05. Right, just connect these custom node to the both of the add nodes, and we're good for this one. Okay, right. This will do two things. Earlier, when I multiplied the UV, it zooms the player's perspective according to the zoom scale that it's specified in the parameter. And then after that, using both the add nodes, the custom node that we created, it automatically calculates the offset of the specified zoom to make sure the effect stays at the middle of the screen. Feel free to modify that formula that I used earlier if you have issues. Then after that, I just copy and paste the scene texture and component mask earlier because we just need it to be magnified and then connect it to that section of code. Right. Just tidying up here a little bit. Right. For the last part, we are creating the scope zoom mask for the mesh. It'll make sense later. But yeah, I'm creating that. Okay. Yeah, create a screen align UVs node. I just copy and pasted ones from earlier. Then create a scene texture node. And then change the scene texture ID to custom depth. All right. After that, I'll just copy an earlier component mask to make it easier. But yeah, create an component mask and make sure only the R is checked. All right. All right. Just writing this out. After the component mask, create another divide node and change B to 255. After that, on out on the out pin of the divide node, uh, just need to create a clamp node. No need to change the values and should be at 0 to 1 for the min and max respectively. All right, the section's done. And what this does, this section, is it checks the post-process mask mesh on screen uh, in the custom depth layer. It'll make sense earlier, but it basically scans the screen for the zoom mask mesh that we will create and assign later, and then zoom applies the zoom effect on that area on the screen. Yeah. Right. The last part is I just need to create a linear interpolate node here, and then just check connect the pins. But yeah, I'm just gonna check if it's properly working for now. So just checking the no zoom. Yeah, there we go. And here I check the zoomed, and as you can see, as I've mentioned earlier, that I made some errors with the formula and it's not perfectly centered. I'm just gonna skip to the part I fixed it. So yeah, 0.05 instead of or zero point 0.5 instead of 0.5. All right, there we go. All right, all good. Let me just connect it the key and zoom one on yeah on zoom one. Just connect it to B. Zoomed connects it to A, and the mask connected to the alpha. All right, we're done here. Just tidying it up, and yeah, we're done. Next, to import the demo meshes, use the link I provided to the zip file, the demo assets that I'm showing on the screen now, or check the text version. I'll show it later. Next, create a new folder named Scope. Right click on that folder to show Explorer. And just drag the assets in the zip file that you can find or that you downloaded to that folder. Yeah. All right. Just drag that. These are demo meshes meant for testing the functionality, just to demo the zoom, right? Just checking this if the sockets I created are still there. Yeah, they're still there. Yeah. And I'm just gonna check the PiP mesh or PP mesh. There we go. You can find the first person blueprint mesh under first person um, under that blueprint, and it's named at BP underscore first person character, and open it. Now that it's open, place the two demo meshes that we you have taken earlier and place it on the camera for testing purposes. Let me just put it there. Let me just, yeah, I'm just adjusting so it can easily be seen when we adjust. All right. Yeah, yeah. Just gonna drag and drop the meshes instead of manually adding them. There we go. Come on. Just drag and drop them. on. There we go. Another one. There we go. Now I will arrange this to the um, scope mesh attached to the camera and the post-process mask mesh attached to the scope. Then I will change on the PiP scope. I will change the socket to M, our PiP reference, to make it aligned properly. Right. Next, for the settings for the transform of the scope itself, I will change it so it will be seen directly to the camera. Just change it to the location to X as 18 and Z as 4.5 or negative 4. Or yeah, 4.5. And then I'll make the rotation for Z as negative 90. All right, let me just check in the game if it's properly aligned. There we go. It's properly aligned. Good, good, good. Now for the important settings under the or in the properties of the PiP mesh that you got earlier, go to under rendering, advanced, uncheck render in main pass, and uncheck render in dead pass, and then check render custom dead pass. All right, let me just find it. There we go. Let's check it. All right. Next, add the post-process component to the character itself. Just it doesn't matter where it's attached. I just attach mine to the camera. Then after that, I made sure unbound is checked. And then after that, under post-process volume, go to the rendering features and then open post-process materials, add an array element, and then add asset. Add the asset we created earlier for the materials, that M underscore site underscore post-process. All right, we should be done. And I'm just gonna hit play and see how the zoom effect looks. Just all right, just minimize this, and all right, and hit play. There we go. There's your zoom. Right, we're done. All right, now that we're done, let's compare results. For this, I'll compare 3 perspectives. 1, no scope, the baseline performance. 2, post-process scope, the one we just created. And 3, I also created the traditional picture-in-picture scope zoom for this demo. Right, as you can see here, barely anything on the demo, the picture-in-picture scope shaves off about 10 FPS of performance. Compare that to the post-process scope, it virtually doesn't impact your performance. Seeing it, the impact is minuscule. Things to keep in mind. I don't really know how to name this section, so I named it as things to keep in mind. Basically, here are topics worth analyzing or considering if you're thinking of implementing this to your game. First, this implementation uses custom depth. Always keep in mind that this implementation uses custom depth. It might cause some conflicts to other features that might utilize this function in Unreal. There are other plugins or marketplace add-ons that uses this feature. In the event that you want to employ this method, try to find workarounds, and that conveniently leads me to my next point. Next, learning about Stencil Depth. It's generally a good idea to learn about Stencil Depth if you're considering this implementation. This way, you can implement multiple features that utilize the custom depths in Unreal. This is also required if you're planning on adding special kinds of scopes like thermal or night vision or even quad nods or NVGs, as I guarantee that you'll also need custom depth to mask the players for the thermal features. image quality concerns. As I've shown earlier, you gain a really good performance advantage for this approach compared to the picture-in-picture scopes. But unfortunately, the biggest downside of this approach is image quality. What you're essentially doing with the zoom effect is stretching the pixels on the screen. And also, this means that if you push the magnification too hard, the image on the scope will be unreadable. So it's up to you to decide on how we work around this. Resolution scaling, maybe. Personally, I have liked to play around with the camera FOV in tandem with assigning the correct post-process zoom to get a desired result. Beyond post-process scopes, you can use this method of magnification not only for scopes. You want a little bit of magnification in the red dot? That's definitely possible. You can even design NVGs, visors, with this in mind. Feel free to subscribe and leave a like if you found this useful. If you want to see this in gameplay for yourself, feel free to check or support my game on Steam. I should have a demo up when this video goes live.